Okay, C4H8O. This is spec number 3 that we're done. I see it says number 8 here, I understand. But this is a different numbering system. Okay, C4H8O. 4 times 12 plus 8 times 1 plus 16 is 48 plus 8 plus 16, 56 plus 16 is equal to 72. This is 72. Therefore, the molecular formula equals C3H8O. Alright? Now, before we go anywhere with this, I'm going to say to myself, what are some possibilities for C3H8O? 1, 2, 3. That's not C3H8O. That's C3, that's true, but that's H. There's H right there. That's H6O. Okay. So C3H8, is that right? C3H8O? Okay. C4, oh, no problem. Okay, I'm thinking. Alright, C4H8O. It could be that. That's 2. There's a hydrogen there. 1, 2, 3, 4, 5, 6, 7, 8. That's a possibility. Or, that's a possibility. Or, that's a possibility, right? That was a 3. We're looking for C4H8O. Okay? These are all possibilities. So I'm looking, obviously the telltale sign is the carbonyl carbon. Let's look and see if we've got that. 15, 16, 17. Boom. Yeah, so it's carbonyl carbon, so it can't be that. It's got to be this or that. And those are the only two possibilities for this. Okay? So obviously the difference between these two is connectedness or connectivity. So I'm going to consider these two separately. Let me consider that one first and say, oh, let's go ahead and mark that. That's, okay. By the way, I recognize that peak, right? It's about 3,000 sp3 hybridized carbons with hydrogens on them. Similar to ones we've done very recently. Type, number, n plus 1. Oh, actually, you know what, we can do this even faster. We can go through and count the unique hydrogens. That's 1. I'm going to call it A. These are different, B and C, right? Because that C is next to a carbonyl carbon and that B is not. A, B, C, and D, right? Or A, B, and C. A, B, and C. These are the only two possibilities. So it either has 4 peaks, or 4 signals, or it's got 3. Let's peek and see at the NMR. Wow, 1, 2, 3 signals. It's this. Only has 3 possibilities. So let's go ahead and write this out. Type, number, n plus 1, and shift A, B, and C. I'm going to call that A, that B, and that C. Alright, so how many are A? 3. How many neighbors do they have? 0. It's going to be a singlet. And it's right next to a carbonyl carbon, which we found was right here, 2.1, right next to a carbonyl carbon. Yeah, I know, you're tempted to peek at that. Let's don't. B, there are 2. How many neighbors do they have? 3. So it's going to be a quadruplet. And it's right next to a carbonyl carbon, right? And also next to it, you see it's right next to a carbonyl carbon? So it's probably also close to 2.1. I know, you're tempted to look. Now look at this, C. C, there are 3. How many neighbors does C have? 2. So it's a triplet. And it's close to 1, right? Because it's just right next to that. It's probably drawn upfield a little bit because these other guys are upfield. But I'm going to still go with the actual number. It's a CH3. I'm going to say 0.85. Alright? So, look at this. The easiest one, this one is the easiest one I think to see because it's off by itself. See? We're expecting a triplet. That's the multiplicity. Boom. With a 3 next to it, that's the number. Okay? So this is C. Now, B, these two are right on top of each other. We're expecting a singlet with a 3 next to it. Boom. Right there. That's A. Sorry, circling too many things here. Okay, and we're expecting a quadruplet with a 2 next to it, and that's exactly what we have. Okay, so these are B's right here. All right, and that's it. That's it for that spectrum. I think we're going to stop for now. That's it, right? You see how we got the molecular formula. Each time we take the empirical formula, find out what the weight of that is, and then we say, is it 72, or is it 2 times that, or is it 3 times that? Whatever it is, then we decide that that's going to tell us what the molecular formula is. That's entire full credit for mass spec. Then we go to IR. Oops, I forgot to label that. That's a CSP3 hybridized, right? Okay. And then everything else that looks interesting as upfield is in the fingerprint region. Okay. So we identify the 2, and that's all the features we have in this thing. Okay, it's just those 2. We don't, IR doesn't. It surely has some absorption there somewhere, but it's not a telltale one in our sheet. Okay. All right. Hope that's helpful.